So, members of the panel, Alan was our speaker, Bob was introduced already, Andrew Banasiewicz, professor at Boston University I wanted to say of analytics, but it's administrative science and analytics. It's in our administrative science department at Metropolitan College. Then Professor Suresh Kalatur, who is with computer science department, and he's the leader of the analytics curriculum development at computer science department. And we have another leader from the administrative science department, Dr. Vladis Latev, who is professor at the administrative sciences department, and he has been one of the main champions of analytics in the administrative science department. And George, we have already heard from George. I'd like to thank him for the presentation. So I'd like to start with I'd like to ask each member of the panel for introduction, a brief statement about the special area of involvement in data analytics, and then we'll start with other questions from myself or from the audience. So Bob, please.
Thank you, Lou. Hi again, everybody. This is Bob Bree from the IBM Academic Initiative. My involvement with analytics, specifically within IBM, is that I, as I mentioned earlier, lead what's called the Academic Initiative in this region. I partner with universities. I assist faculty with the adoption of big data and analytics technologies in their curriculum and their courses. I first started getting exposed to analytics as I was working in Software Group, as what's called I was an acquisition enablement manager in IBM. And about 8 years ago, we started acquiring a lot of different technologies in IBM, as I mentioned earlier, $17 billion worth of acquisitions. Companies like Cognos. I first started getting exposed to Cognos about 7 years ago. IBM invested $5 billion in acquiring that one company alone, as an example. SPSS, other set of technologies some of you may be familiar with in terms of statistics, but we also have data modeling and decision management. So my exposure to analytics and big data has really been from working with IBM, teaming with our technical sales and IT architects over the past several years, and now in the form of working with faculty and assisting faculty as a curriculum consultant and bringing in volunteers and ambassadors to partner with our university faculty partners. So again, good to be here on the panel. Looking forward to chatting with you.
Hi, I'm Ellen Eid-Kislow. I have worked for a number of years in various machine learning type projects, and I did consult for a big data company in 2013. I would say my expertise is more on the analytics side than on the database side, and it's interesting that even though my education and early experience was in the speech recognition area, it was very relevant. So I was able to bring a lot of NLP knowledge and maximum entropy modeling techniques to the space of big data analytics. So that was nice and rewarding, and here we are. So that's it.
Andrew?
Hello, Andrew Banasiewicz. I'm relatively new to Boston University, and prior to joining the faculty, which I did a couple of years ago on part-time basis and just about a year ago on full-time basis, I spent, I don't know, about 17 or so years working in the industry. And so I worked in an area which right now is known as predictive analytics. So I started out in the marketing area, working for a large research company called Nielsen Research, and then about halfway through, I switched and went to work in risk management. And so throughout the entire 17 or so years, I spent just about all of my time developing predictive statistical models for various decision-making purposes. So a lot of the opinions that hopefully I get to share with you today are frankly informed by quite a bit of experience that I've had in the industry. So glad to be here as well, and glad to share the panel with my my colleagues here.
Thank you. Suresh?
Yeah, I'm Suresh Kalatu from Computer Science Department. So my interest in the analytics or data mining started way back. So in 2005, we started our first data mining class. So at that time, so teaching the class is one thing, and also making, giving interesting topics to the students is another issue. And I was interested in seeing what are the things that are relating to data which appear in everyday news. And I started collecting them, and I realized that we need to have a better way of doing it. So I started writing a program. And at the same time, my son was in middle school, and they had these competitions about the news events. I said, okay, I have this program. I can input the data into the program. And then he's fine. He went to the college, and he's done with that. And now my daughter is in the middle school, and I said, okay, I'm not going to enter all the data, all the news items all over again. So again, I wrote the program, which will automatically collect the news items and keep it in the database. And she will come to me and say, Dad, tomorrow I have the test. I need the last 2 weeks' news items. Here we go. There comes the printout. Okay. And if you have a middle schooler and they do the current news, so just let me know, and I'll be happy to share the information. They're guaranteed to come in the top 5 of the class. And there are various other things. Yeah, anything that is related to data. To most of you, you in everyday life, all right? So unless you are a millionaire, you are interested in what is happening to your money that is coming in and going out. You drive your car every day. You're interested every time you fill up the gas and you see the bill, $50 for filling up the tank. You're interested in how much mileage it is giving. So unknowingly, you're actually looking at the data in everyday life, and obviously, through our courses, we are going to explore that type of data and see what we can do with those data. All right, thank you.
Hi, my name is Vlad Zlatev. I joined Boston University 4 years ago. I'm an industry practitioner. My background is industrial engineering and management. I will define our mission to teach students how to apply analytics using the 3 pillars of the analytics cycle. The first one is industry knowledge. Second is how to analyze data. And the third is you as an expert who is changing the picture by applying all these analytical tools, but also learning more about your profession. So in our programs, we are applying a lot of models and instruments thanks to IBM. 3 years ago, I introduced to my students SPSS statistics and how to apply it in a course called Market Research and Analysis. And sounds complicated, but it's extremely powerful. And we are still using these instruments on a daily basis in other courses, including quantitative and qualitative decision making.
Thank you, Vladi. George, tell me, how is it to be a computer scientist in a marketing department, a traditional marketing department?
I think my colleagues suffer more than I do. So having actually, it's really interesting. So I've traditionally worked with data, but sort of been completely blind to decades of management and business research. My background is in computer science, my undergrad, my master's, my PhD. I ended up in the marketing department, and I'm very fortunate because now I get to test the predictions of decades of marketing research using data, which I love to collect and analyze.
Thank you. I'll start with the first question, which is what are the main career paths and possibilities that you see in data analytics? So anybody from the panel can answer that question.
Thanks, Lou. It's interesting. From a industry perspective, IBM Corporation, we have a lot of clients. We have a lot of our Fortune 500 clients who invest in data and analytics in various different ways. I think what we see, and as I partner with universities, there's this rise of data scientists. That's obviously a title, it's a discipline, but we also see data. Data is this one thing that is providing opportunity for people outside of what might have been traditionally been computer science domains and disciplines, as George's presentation and marketing covered, right? Developing new models, understanding customer buying patterns, looking for upsell, cross-sell opportunity. We're seeing analytics. We work with an organization in Europe that and creates large wind turbines, right? Understanding weather patterns, understanding how to get maximum efficiencies of these things. We work with Toronto, a hospital in Toronto. So medical fields, right? Understanding data analytics and doing predictive analytics with health teams to provide better opportunity, for example, in this case, identifying sepsis a full 24 hours compared to traditional means in a neonatal care unit. So we used to talk about computer science domains, but data, understanding data, analyzing data, interpreting data, doing predictive analytics on that data is now a skill that we're finding in many different disciplines. And it's hard to determine those just by title alone. And so there are other reports that have come out recently, even McKinsey, we talked about the 2011 report, but even McKinsey in March 2014 came out with a report saying 50% of CIOs are saying that they're having a very difficult time recruiting talent, IT talent, as relates to big data analytics. Not just recruiting, but maintaining and developing that talent internally. So it's a current thing as well, and it's happening in many different disciplines and many different domains.
If I can add to this, based on my experience, what I've observed, what has been happening over the past several years, because as was illustrated earlier, the amount, the volume, the veracity, the variety of data has exploded so rapidly. The term data scientist is becoming, and I do agree with my colleagues that it has been the occupation du jour, if you will, of the past few years, and I have a number of former colleagues and friends who do bear that title in various industries. But it's becoming more and more industry specific, because when you think about it, the types of data that different industries have. So for instance, when I worked in marketing, and the data that marketers typically have, and a lot of it comes from electronic transaction processing systems and like mechanisms that virtually all companies basically share in common. And then when I switched over to risk management, completely different data coming from completely different sources. And so in order to be data scientist, sometimes we glaze over the term data and start to think automatically in terms of statistical methodology. But what happens, the differences in terms of the data itself are so significant across these different sources and types of data, and the techniques that are used, and both for data manipulation and transformation as well as for data modeling, are so typically different. So in insurance, the assumptions, the techniques, and the type of data are very different than those used in marketing. And so what is the reason a lot of organizations have difficulty filling these positions is because if someone knows statistics, but they don't know the idiosyncrasies of particular type of data, then it's a fairly long learning curve for that person. And so the companies want to find someone who has that particular experience with that type of data. And so, so I think for us as educators, that means that we have to bring more of it to the classroom, because, I mean, where do people learn it? So it's a chicken and egg, right? I mean, if you have to have experience in order to get job, and you can't get job without getting experience, then something has to give here. So so I think the importance of understanding the specifics of a particular type of data have been accentuated by the rise of big data, and the fact that in every aspect of industry there is so much of it, so much so that that one needs to really spend quite a bit of time to understand it. And I do know it from experience. It has been painful getting into a new area, because you make an awful lot of mistakes and spend way too many hours working out certain problems. So anyway.
Just to piggyback on that a little bit, one thought that came to my mind is it doesn't have to be a single individual. So we can, bring together teams of people. So we have a domain expert who knows a lot about medicine, but not too much about computer science, and put them in the same room with a computer scientist, and good things can happen. And then from the computer science perspective, also, the better job we can do at distilling the data and presenting it in a simple, intuitive, easy to understand way, the more pervasive it will become, I believe.
So briefly about the career paths, the question Lou asked. So obviously, I knew the question is going to come. So sitting there, I looked up on the job website and looked at the various types of positions people ask, and most of them, they relate to data analysts, data scientists, business intelligence analyst, and so on. Obviously, all of them require the core background, the analytics background, and then depending upon the type of industry you're going to work, so the terms are actually different. And one interesting job that was listed is a passport fraud data analyst right in the Boston area. All right. So there are various companies which are interested in hiring the people in these backgrounds. And it's our intention to actually get together to develop the set of courses which will train the people for those specific areas.
One critical application of data analysis is to understand and read the performance of a process or a project or a company. So in my opinion, that's one of the most challenging but also promising area, how to evaluate organizations and or projects based on your reading of the data. So and our challenge and opportunity is to teach our students how to do this.
Thank you very much. Do we have any questions from the audience at this point, or online as well? Any questions from the audience? So the question is how specialized the statistic is versus the data mining.
Well, you know, we do have a bit of a problem with definitions, because the term data mining itself means different things to different people. So oftentimes, like for instance, when Ellen was speaking about natural language processing as a text mining tool, well, that's data mining, but you can mine numeric data just as well. So with that in mind, there's a question of application. So IBM's SPSS, for instance, and its competitor SAS and the open source R applications all basically do the same thing in a little bit of a different way. But the idea is that in order to use certain type of data for making, let's say, certain types of predictions in different contexts, there are oftentimes different assumptions that the data meets or doesn't meet, which then kind of points us in the direction of different methodologies. So the idea is that, you know, you can't almost do a good job with one without having adequate control or command of the other. So you know, the days when traditional statistics courses were taught, you know, the data was presented as this very simple, you know, we have 200-300 observations from some, you know, almost ridiculously simple survey, and then the focus was all on the methodology. And nowadays, I think the data has to be transformed in so many ways, oftentimes, simply because the way it comes out of the machines that capture it is not analysis ready. And so depending on what data you have and depending on what kind of outcome you want to produce, it's going to push you in a direction of different techniques. So you have to understand enough about how to manipulate the data and correct the various challenges that it comes with. And then you also have to understand the statistical methodology. Hence the term data scientist, at least the people I know in the industry, tend to have, say, PhD in statistics and also considerable experience in data manipulation technologies, working with SAS, SPSS, R, and essentially getting data ready for analysis. So that's the point where, you know, you really have to combine the two. Otherwise, you just become a person who prepares data for someone else to analyze. So you're not really a scientist. You're kind of like a data clerk, for lack of a better term.
May I add something there too? I think that's a great point, Andy, in that the term data scientist, although it's becoming the buzzword the same way big data is, there is distinction. And I think the statistics background, the programming background, you start to see this manifesting itself in job postings and things like that, where maybe, you know, some of the data we show says that 40% of some of our ecosystem, for example, are looking for business analysts. The business analysts maybe interpret the data, make decisions on that data, but maybe it takes that data scientist to really bring that forward with a strategy, maybe bring that forward to create those visualizations to allow those business analysts to make the appropriate decisions. So we also see a pattern, what we've been calling T-shaped skills, literally a T, if you will, depth and breadth, that in which you have industry expertise perhaps, maybe you are that programmatic skill set, maybe, for example, 39% of our ecosystem saying they're looking for information specialists and cybersecurity specialists. You can't separate those two topics, right? So you start to see where this coupling of skills, industry skills, data scientist skills, but maybe in the business analyst, it's interpreting that data, understanding the data, deriving meaning behind that data, deriving knowledge from it in the industry context. So whether it be in a technical background, depth and breadth. Business context, depth and breadth as well. And so I think, to Ellen's point, organizations are looking to couple these skills together in a particular role or assembling teams. And I think that's the most important about this, that communication skills, since we're talking about skills, teaming skills, these are also very, very important skills that have nothing to do with the IT technical aspects of this, that are very important for someone working in the field of big data and analytics.
Thank you, Bob. Was a question from another or comment?
So we are talking here about big data.
Information, knowledge. Yep. Yep.
And there is good understanding that we have ability to process and just compare data is limited by explosive growth. However, I can see that most of projects that fail, they don't fail because of statistics. We have enough statistics. We have enough tools and techniques. It's obvious that asking wrong questions. And how do we educate people? Talking about those analysts, but also there is high level of knowledge workers, so that we can integrate the whole process. And I think it's definite need in education. We're going along the pyramid, not only at the bottom level.
Yeah, I think this is a very important point. So being an analyst, it's not one size fits all. It really has to have expertise also in the specific area of interest, because as Andy pointed out, if you're working in healthcare, or you really need to have input and to understand the healthcare data, whether that's images or other type of data, or genome, who knows what. But the question is, how is this area specific, and what kind of expertise, what kind of depth do we need in the specific area for the people that work in analytics? In this case, with case of George, we have a computer scientist who is, who has practically, all the expertise in the computer science and works in the marketing department. How can we understand the level of depth that is needed by the industry in specific fields?
Well, if you look at how we taught statistics historically, aside from the fact that we taught it in on a very limited basis, unless you happen to study statistics, it just was usually one of those bitter pills that one had to take, and you take it once, you get through it, and then you'd never have to deal with it again. And obviously, unfortunately, that for those who felt that way, that is no longer the case. And so, but I mean, realistically, what I think, in order to get to your point, maybe what we should do is start, as opposed to focus on methods first, and then teach those in this kind of an esoteric, abstract, it doesn't really mean anything to anyone. It's yet another branch of mathematics where these ideas that people can't relate to are being forced on them. And start from the other end of the continuum, which is simply to say, here's the business problem. So if I'm a marketing manager, I need to understand how to attract more high-value customers. Well, how do I do that? Well, there are ways of doing that using data, using information about your current customers, and so on. And so if we start from that and work backwards and then say, okay, so what kind of data do we need? And vis-a-vis what do we have? Well, how would we take the data and analyze it in order to answer that basic business question? And then basically back into some, whether it's some kind of a regression or some other type of analysis, then there is a logical progression, and then the analysis of data and statistical techniques become means to an end, as opposed to these yet another example of, the abstraction that one has to learn for no particular reason. And so I think if we do it in that way, it's going to reset the mindset in terms of, what is the analysis of data and what ultimately what purpose it serves. And that's been, again, my experience of how it can be made, how we can train someone, because I had to do that to younger analysts. How do you teach someone to analyze data so that they're not just crunching numbers for no particular reason, but arriving at answers to specific questions?
Q, any other comments?
I just wanted to add something to your question. You might find the answer you're looking for. So I was reading recently a book by Kaiser Funk called Number Sense, and he uses the term number sense to describe exactly what you're talking about. As you pointed out, most analyses do not fail for a lack of statisticians or computer scientists or data. The fact is that we can answer many more questions. Many more questions means many more mistakes in answering the wrong questions, not giving the wrong answers. So developing that skill that he calls number sense seems to be difficult. I don't know how we're going to do it, but maybe you want to take it. Get some really good insights.
Well, the answer. But I think the fundamental piece is the structuring the whole. And I think the point of education here is also that group of people proper application. Educated because times data speak by never spoke to me.
Okay, any other question from the audience, please? I will just repeat the question. The question is, what are the best business analytics programs, and based on this for Bob.
My observation has been the past 5 years, schools of business, marketing programs, schools of business have moved very, very quickly. They've mobilized to evolve, tweak, update their programs to provide masters in business analytics, concentrations, track certificates. RPI, for example, in New York, Troy, New York has offered a master's in business analytics, and they offer some pretty nice programs in terms of business intelligence, data mining, predictive analytics capabilities, and they're using some of our tools for that. They also have quite a bit of work going on with our Watson team. So RPI is one of the only universities that has a Watson, a cognitive system environment. And some fairly substantial research efforts going on the way there. University of Virginia, I've also worked with them in the past, so my colleagues cover them now. A really good program in the past 3 or 4 years in terms of McIntyre School. We also have universities on the West Coast, of course. We have Northwestern, for example, DePaul. Fordham University in New York is another school I've worked with a master's in business analytics that cover that whole spectrum of business intelligence, predictive analytics, data mining, text analytics, data warehousing in the School of Business. But most importantly, in the context of solving business problems. And so I think what I see a pattern here with a lot of these schools is that many schools have been rolling out these programs, looking for industry context, providing, to your point, Andy, earlier about hands-on experience with industry tools, not just IBM tools, of course, open source tools, other vendors' tools, because those are the tools that are being used in industry for these marketing programs, or fraud detection, or financial risk analytics with things like algorithmics, now part of IBM. So I think we see a really good pattern here with the business schools mobilizing fairly quickly, as curriculum doesn't change very often. But what it does, we see new programs coming out, new masters in analytics. And those are several of the schools that I'm most familiar with that are getting a lot of recognition. Fortune had an article just a few months ago highlighting some of those, as well as others. And we see now the computer science engineering now doing the same, following suit, sort of updating, like here at BU, updating their programs, maybe emphasizing more areas, like Professor Schuette's courses on advanced data management, and others here at BU that are updating and revamping to provide students a better opportunity and weaving in some of these technologies in the computer science engineering domain. So hopefully that answers your question on some of those areas on the business school aspect of it, MBAs, and there are more coming. More universities are waiting for state review, if you will, and other certifications to make such similar announcements. So thank you for your question. It was a good one.
Okay. Another question from the audience or online? So the question is whether there is going to be a diminishing need for relational databases as we go forward.
Take that one if you'd like. What's happening is a revolution phase. What's some of the things that are happening there? Thank you. My name is Bob Schuette. I teach advanced database management here at BU. What's happening is a major revolution, the biggest changes in databases since the 1970s. And what's happening, it's the big data push, but also it's object relational and other earlier things like 10 years ago. But what's happening is that the major vendors like Oracle of the relational databases are getting integrations with the big data tools. That's still fairly early. We teach that, for example, in the data warehousing course here. And I teach some in my advanced database management course. It's early, but the relational databases aren't going away. In some ways, their power is being increased by the addition of these not only SQL or NoSQL database constructs, the extensible databases. The major structural difference is that the relational databases move the data to the engine. So you have these data servers and stuff, and then the data gets moved to the processor. These very large databases, it's just not possible to move the data. It takes like weeks to move some of these data sets. So the queries are pushed to the data. That's the MapReduce and variations on that. So these very different paradigms are being married. That will take 10 years, roughly. These are very hard technical problems. But the leverage from that is huge. So for example, the information that you have on your customers is primarily the stuff you know to be good is in your relational database. The tweets, the cell phone localization data and stuff that'll help you target that customer, the very volatile data, the high velocity data, is coming from other sources. So they're very different in veracity in how you treat them. But relational databases will be with us for a good while. Thank you.
Thank you. Another question from the audience? Do we have a way of getting questions online? Or have you heard any? Polly? No, we haven't any question. I'd like to ask the people who have been dealing with data, how clean are the data? Because usually the data that we get are quite dirty, and there's a lot of work that goes into just preparing the data. And I'd like to hear from George and Suresh and Andre, how difficult and how time-consuming is preparing the data, and what part of data analytics is that?
What part of data analytics is that? I don't know that there is a name for it, but certainly it's a large fraction of our time. So there is an ongoing trend where data is not only dirty by accident, but it's obscured on purpose. So you can think of companies like Yelp that I study that are in the business of essentially disseminating information. So So they would love their reviews to reach the maximum number of eyeballs. At the same time, it would be very scary for them if someone could easily obtain their database by writing some simple code. So they take measures and countermeasures, and there is an arms race in protecting their proprietary data that at the same time they try to make available. So for us researchers, who are generally benevolent, this is a problem, and it takes a large fraction of our time. As a data point, for the work that I presented, I think we spent approximately, let's say, 1 year getting the data, getting it in the right form, figuring everything out before we could start writing the paper. So it's a considerable amount of time, but it pays dividends, that's why.
As part of the curriculum, so most of the data mining classes and data analytics classes will have an explicit focus on the data cleaning part. So obviously the data, depending upon what type of application you are going to deal with, so the data is not going to be clean, and especially if you're talking about the reviews that the user is going to type. So obviously if they're sitting on the desktop and then typing, you can expect a little bit more cleaner version of the comments. But if you're typing with your 2 thumbs on the cell phone, obviously the text is not suitable for our data pre-processing task. So different types of tools, they actually provide the various analyzers to actually look at the data and then make meaningful sense out of those data. So they are part of the curriculum itself, where we explicitly focus on how getting the data is one part. Where are we going to get the data? We assume that we are going to get the data from the trusted sources. But once we get the data, how we process the data and how much noise was introduced in the data. It doesn't have to be the text comments. It could be any measurements through any instruments that we are dealing. If you're consistently seeing something that is going wrong, so we need to find out where the errors are coming from and then rectify those errors. So all those are basically part of the data cleaning process. And most of our courses, they have, at some point we assume that the data is clean and then move on. But when you come to that, prior to coming to that particular process, so there are various techniques that we use to actually clean the data and then process the data.
Now, in terms of industry work that I've been doing over the years, if I had to guesstimate, and it is a guesstimate because I didn't keep track of it, for every hour I spent doing the actual modeling, I had to spend at least 2 hours doing the data cleaning and preparation work. And quite frankly, preparing the data for analysis is far more difficult, largely because there are unexpected and unforeseen challenges, some of which are systemic. So if our data is collected a certain way, then it may need to be restructured. If it's unstructured data, then we need to imbue some sort of a structure into it, whether by means of text mining, extracting some insights that we turn into variables and so on. But even if that's not the case, then there are deficiencies in the data. There are missing values, there are incorrect values, and so forth. So there is no simple solution to any of it. It basically always depends, and so it's time-consuming, and it requires a strong understanding of the data itself, and frankly, it requires some imagination too. And so all of that means that it takes up quite a bit of time, and it takes a fair amount of skill in order to be able to do it correctly. Now, thanks to the tools that we have at our disposal right now, so if it's SPSS, SAS, or all those well-developed, mature statistical analysis packages, the actual analysis takes relatively little time because it's been automated to the point where if you know what selections you're choosing, what you're pointing and clicking on, or put in a short program, well, then it's a fairly quick process, but the data prep can be very, very time-consuming, and that's where real mistakes are made because it's the traditional garbage in, garbage out, and so that's the biggest I think challenge, and that's the area that historically we haven't emphasized in our instruction, and we do frankly need to do a better job of preparing students to be able to do that better.
I just wanted to add one quick point to that, which is I found that actually the missing data that Andy mentioned is sometimes a big problem and an interesting problem, and it's a little bit of an art in terms of what to do with it. So if it's 0.5% of your total data, you may just throw away those records. They just don't matter. But if it's a significant portion of the data, you may want to choose a model which tolerates missing data. So you might want to build a Maxent model, for example, which can handle those sorts of missing fields. So it's kind of an art. That's where the art comes in.
Thank you. Please.
So my field is in bioinformatics and immunoinformatics. So basically I deal with biological data and immunological data. And data in those fields, mostly there are variety formats of data, and the data quality is also vary a lot. So I would say when I do data analytics in this field, half of my time spent on data cleaning, organizing the data, process the data. So there are tools that we can use to formalize the process, for example, taxonomy, nomenclature, and there is a great need to set up proper nomenclature and proper structure of the data, at least in many fields, not only in biological, also in healthcare. Later I moved into health informatics. So because of the government is injecting $27 billion to promote healthcare IT. So with all this digitalize of our healthcare data in all kinds of different formats. So if we want to do analytics on this data, the prerequisite, the first step is to properly organize the data, put them into certain standards, process them into certain standard according to certain taxonomy, certain nomenclature. So it is an important topic in the field.
Thank you, Guolang. Obviously, data preparation is important topic. Data analysis is the second one. And the last one is data visualization, which is essential for presenting the results. And we didn't have chance to talk about it, but it's a major part, I think, of data science. And but I'd like to, that I'm trying to be aware of the time, and I'd like to end up with a question to ask our panel members. What are the top new areas or new opportunities in data analytics that you see over the next 3 to 5 years? Like some areas that have not been seen. Like recently I saw using analytics in human resources or evaluating nurses, or there are really areas that that we have in education is one thing. We are monitoring our courses, but what are, in your opinion, the areas of growth, the new areas of growth over the next 3 years? Please. Andrew?
Well, one area that has been sort of the holy grail in a lot of industries is that of multi-source analytics. So when you marketing tends to be familiar to most people. So when you think about, I think George, you mentioned someone mentioned 360-degree view of customer, which is what most marketing organizations want to develop. Well, how do you do that? You basically have different data that pertains to different dimensions of consumer behavior that comes from different sources, and it's different in all imaginable ways. But the goal is to ultimately pull it all together into a singular informational reservoir, and in order to and analyze it as all these different data points as sort of attributes of a single customer. In order to do that, all of the data has to be amalgamated together and made into one whole. And then so that it all can be analyzed, so we can see how attitudes, for instance, relate to actual behaviors and so on. So how online behavior relates to offline behavior. And so all of that falls under this one general umbrella of multi-source analytics, which is essentially the skill that it takes to be able to take differently sourced data and mash it together into a singular reservoir that then can be analyzed as one. And virtually in all aspects of industries that I've worked on, that is something that is of great importance.
One of the largest consulting company in the world is in Boston. It's called Bain Company. And they are publishing every year a list with areas where analytical tools are extremely important. And in the last 3 years, human resource is one of the top 3 all the time. And the trend is that the future companies will search for talent and will reverse the current process that you are applying for a job. They will ask you to join the company based on information about you as a candidate. Another very important area is risk assessment. The enterprise risk management is becoming a very powerful area where risk is not a catastrophe-related event, but opportunity, and how to assess and organize the life of the corporation based on all these new reading of the data is the challenge, but also opportunity for the industry.
Thank you, Vladi. Any other areas or that?
Thank you. I started my talk earlier about just talking about the convergence that we're seeing, the convergence between data as that natural resource, cloud computing, the ability to not only consume IT services, but deliver IT services. And the third area is really what we're calling systems of engagement. That is, taking advantage of and leveraging the 1 trillion devices, the rise of mobile, the rise of social business, social networking, where we're seeing a lot of interest and a lot of inquiries and probably investment. If you look at IDC data, 30% growth of big data on software and services, it's really exposing where there is a shortage of this big data and IT skills as it relates to big data, cloud computing, and mobile. And so security is that one of those areas that really brings all that together. So I think we see a lot of organizations really trying to understand how to best govern, leverage cloud infrastructures, hybrid platform as a service, infrastructure service as relates to data and security. Having it being built and managed and governed. And so we see a lot of investment in that cybersecurity, cloud, and data. It's really the convergence of those 3 areas that organizations are really, really looking to bring new talent, but also continue to innovate.
I think this is a very good point, especially when we talk about the Internet of Things, and the other part of the equation, which is privacy, that will be, and it is already an essential part of data analytics. There was a question from the audience. Yeah, so let me just repeat the question. The question is, if you have a computer science degree, what kind of specialty you need in the specific area to find a job, which is related to the career path. So anybody from the panel? This is related to the question that we addressed. What kind of expertise do you need in a specific area? And the trend that we were seeing earlier, like a financial industry was hiring a lot of physicists traditionally, people, they were basically doing analytics and modeling. But so when instead of doing a lot of postdocs, they will go into finance industry and make money. So the similar was the trend in the other industries. But I think that with healthcare, we see that health informatics is becoming very clearly defined discipline, when you need to know the medical terminology, you need to know the systems that are being used, especially for electronic medical records. So it really depends on the area, and from what I see, it has to be more specialized. George, from
I think it has not changed much from what you described in the following sense. My experience is that there is tremendous demand, seeing the students here at BU, for those with computational skills. And there is no need for hardcore specialization because in my experience, in many cases, large companies at least have the resources to provide that training to their employees. So if you go and work for the Googles and the Microsofts and the Apples of the world, I think they would rather train you. So even an undergrad computer science degree, I think, remains immensely valuable. That's my experience.
What I would suggest, again, based on my own experience, is skills and tools. I mean, imagine if you go on a job interview, if I sit across the table from you, it is very difficult for me to discern whether or not you have the capability to learn because of just, it's hard to assess idea. Now, it is fairly easy for me to determine if you have the right skill sets and if you are familiar and have some fluency in the basic tools. So if you want to be a data analyst and you know, I want to know, have you done that kind of work? Are you familiar with, at least have rudimentary understanding of SAS, SPSS, or those kinds of tools? Because, you know, organizations right now depend on people doing work that way. And so, when the choice comes to someone who walks in the door and says, I have done this work, I have at least rudimentary understanding and hands-on knowledge of those tools, and I have these kinds of skills of, you know, I've manipulated these kinds of data, I did those specific activities. That's one way to distinguish yourself and get a leg up on the competition. And generally speaking, people like that will win over, because if I'm your manager, last thing I want to do is spend half of my time training you, because that means I have to work, you know, 50% more time. And if I'm selfish, I don't want to do that. And most people, unfortunately, are selfish. And so that, and as far as the degree, I would suggest get a job first and figure out what is it that you really want to do so you can choose wisely when it comes to the next stage of your education. Because sometimes things look one way. Once you get in, you know, into that area, you realize, you know, that's not quite what I thought it was going to be like, and then you may want to make a switch. And so once you find a place that you're comfortable in terms of the type of work, then that should direct your next educational endeavor, I would think.
At this point, I'd like just to summarize with things that no matter what you decide, you will have to plan on continuing to learn as you go. And that's what I think it's a must from what we see. So many of these areas were just not there 10 or 20 years ago, or even 5 years ago. So continuous learning is really a must. I'd like to, and this is a very nice introduction into our next panel, which will focus on the educational programs in analytics. So at this point, I'd like to thank our panel members for participation, and I'd like to, if you have any questions for them, maybe you can catch them later. But at this point, we can have a very short break and then continue with the next panel on education. Thank you.